Welcome to a peaceful exploration of the gentle rivers that flow through the northern landscapes of Scandinavia. As we embark on this calm journey together, allow yourself to settle comfortably wherever you are, perhaps imagining the soft sound of flowing water in the distance. The rivers of Scandinavia have carved their paths through ancient bedrock for thousands of years, moving unhurriedly across landscapes shaped by glaciers long ago. These waterways connect the mountains to the sea in a continuous cycle that has remained largely unchanged since the last ice age. Tonight, we'll follow these meandering paths, traversing the serene countries of Norway, Sweden, and Finland, as we learn about the geographical wonders that define this northern region of our world. The pace of our journey will match that of these gentle rivers, steady, calm, and without hurry. The Scandinavian peninsula extends northward, embracing the Arctic Circle, cradled between the North Sea and the Baltic Sea. This landmass, marked by its distinctive shape on maps, forms the northwestern portion of the European continent. Throughout our exploration, we'll discover how the rivers of this region have shaped not only the physical landscape, but also the cultural development of the societies that have flourished along their banks. The geological history of Scandinavia provides a foundation for understanding its river systems, which flow with a characteristic gentleness typical of northern European waterways. As we begin to navigate these tranquil waters, picture yourself drifting slowly alongside the current, where the surrounding landscape unfolds at a pace that allows full appreciation of every subtle detail. The rivers we'll explore tonight vary in length and volume, but each contributes to the distinctive hydrological network that defines this northern region. Some rush from mountain heights, while others meander across broad plains, but all eventually find their way to the embracing seas that surround the peninsula. Let us first orient ourselves to this northern landscape, where daylight hours vary dramatically with the seasons, and where water, in all its forms, has been central to the development of the region. The Scandinavian countries encompass approximately 750,000 square kilometers, an area characterized by dramatic fjords in the west, dense forests in the central regions, and countless lakes dotting the eastern territories. Within this diverse landscape, rivers create natural pathways, connecting disparate ecosystems and providing essential corridors for both wildlife and human activities. The geography of Scandinavia has been profoundly shaped by the last ice age, which ended approximately 10,000 years ago. As massive ice sheets retreated northward, they sculpted the landscape, creating the characteristic U-shaped valleys through which many rivers now flow. This glacial history explains the relatively young age of Scandinavian river systems compared to those in other parts of Europe. The weight of ice compressed the land, and as it melted, a phenomenon known as post-glacial rebound began. A gradual rising of the land that continues to this day at a rate of approximately 1 centimeter per year in some regions. the Scandinavian mountains, or Scans, form a natural divide running north-south through the peninsula. This mountain range, reaching heights of over 2,000 meters in some places, acts as a watershed, determining whether rivers flow westward toward the Atlantic Ocean or eastward toward the Baltic Sea. The mountains are not particularly high by global standards, with the highest peak, Galdhøpiggen in Norway, reaching 2,469 meters above sea level. However, their northern latitude means they experience harsh climatic conditions similar to much higher mountains elsewhere. Rivers flowing westward from these mountains tend to be shorter and steeper, creating occasional rapids and waterfalls as they descend quickly to the fjords that characterize Norway's coastline. In contrast, rivers flowing eastward typically travel greater distances across gentler gradients, creating meandering waterways that pass through Sweden and Finland before reaching the Baltic Sea. This fundamental east-west division creates two distinct river personalities that we will explore in greater detail. The bedrock beneath Scandinavia consists primarily of ancient Precambrian shield, some of the oldest rock formations on Earth, dating back more than 1 billion years. This stable foundation means that the rivers have had to work exceptionally hard to carve their channels, often following fracture lines and weaknesses in this resistant material. The result is a network of waterways that frequently appear to follow straight lines for considerable distances before making abrupt turns. A pattern quite different from the sinuous meandering typical of rivers, flowing through softer sedimentary rock or alluvial plains. Sweden's largest river, the Göta exemplifies many characteristic features of Scandinavian waterways. Beginning at Lake Vänern, Sweden's largest lake with a surface area of 5,650 square kilometers, the Göta flows approximately 93 kilometers to the Kattegat Strait, which connects to the North Sea. For centuries, this river has served as a critical transportation route, connecting the interior of Sweden with international shipping lanes. The river drops just 44 meters from its source to its mouth, creating a gentle gradient that has facilitated boat traffic throughout human history in the region. Moving northward, we encounter the Klarälven, another significant Swedish river that flows for 460 kilometers, originating in the Norwegian mountains, where it is known as the Trisulva, before crossing into Sweden. The Klarälven is notable for its exceptionally meandering course as it winds through the province of Värmland, creating distinctive horseshoe bends and oxbow lakes that demonstrate classic river morphology. These features develop over thousands of years as the gentle but persistent force of flowing water erodes outer banks while depositing sediment on inner curves. The human history along these rivers stretches back to the Stone Age, with archaeological evidence suggesting that early inhabitants were drawn to riverbanks for the resources they provided. By the Viking Age, from approximately 800 to 1050 CE, rivers had become essential transportation corridors, allowing Scandinavian explorers and traders to penetrate deep into the continental interior. Many of the oldest settlements in the region are situated at strategic points along rivers, particularly at natural harbors or positions above rapids where goods needed to be portaged. The relationship between Scandinavian peoples and their rivers has always been characterized by respect and practical utilization. Rivers provided food through fishing, power for early industries through water wheels, and natural defensive boundaries for settlements. This practical appreciation for waterways continues today, with many rivers now serving as sources of hydroelectric power, contributing significantly to the region's high percentage of renewable energy production. Forests typically dominate the landscapes surrounding Scandinavian rivers, with coniferous species like pine and spruce creating dark green corridors that follow the waterways. These riparian zones support distinctive ecosystems, providing habitat for numerous species, including moose, beaver, and various migratory birds. The interplay between forest and river creates microclimates that can be slightly warmer in winter and cooler in summer than surrounding areas, due to the moderating influence of flowing water. As we continue our gentle exploration of these northern waterways, we might pause to appreciate how the character of Scandinavian rivers differs from season to season. In spring, snowmelt from the mountains and forests creates a period of high flow called the spring flood, or varflod in Swedish. During this time, rivers that seem modest and calm during other seasons can transform into powerful forces, carrying winter's accumulation of snow and ice toward the sea in a natural rhythm that has continued uninterrupted for millennia. Let us now examine the topographical features that characterize the river systems of Scandinavia in greater detail. The fundamental structure of these waterways is determined by the underlying geology, which can be broadly divided into three main zones. First, the western coastal zone consists primarily of hard, metamorphic rock formations that have been heavily sculpted by glacial activity. Second, the central mountain range, or scans, creates the primary watershed divide. Third, the eastern zones consist of lower-lying terrain interspersed with thousands of lakes, particularly in Finland, where approximately 10% of the total land area is covered by freshwater. The Norwegian river systems typically begin high in the mountains, flowing through steep valleys before reaching the deeply incised fjords that characterize the coastline. These rivers, such as the Lagen, Rama, and Atra, tend to be relatively short but powerful, dropping considerable elevations over short distances. The Lagen, for example, descends from the Hardingervidda Plateau at approximately 1,200 meters above sea level, flowing for 204 kilometers before reaching the Skagerrak at Larvik. Along its course, it passes through Lake Mosvaden and the picturesque New Middle Valley, creating a characteristic stepped profile with sections of rapids interspersed with calmer stretches. In Sweden, the northern rivers flow primarily southeast from the Scans toward the Gulf of Bothnia. These include substantial waterways such as the Torn, Kalix, Lule, Pite, and Ume rivers, each draining large watersheds and carrying significant volumes of water. The Torn River, forming part of the border between Sweden and Finland, extends for 520 kilometers and drains a watershed of approximately 40,157 square kilometers. Its annual discharge averages 388 cubic meters per second, with considerable seasonal variation. During spring floods, discharge can exceed 2,000 cubic meters per second, while winter flows may drop below 100 cubic meters per second, when much of the precipitation is stored as snow. The gradient profiles of Scandinavian rivers typically show steeper sections in their upper reaches, moderating to gentler slopes as they approach their mouths. This pattern creates distinctive zones along each river where different ecological communities develop. The upper reaches, characterized by faster flows over rocky substrates, support species adapted to oxygen-rich environments. In contrast, lower sections with finer sediments and slower flows create conditions suitable for different assemblages of plants and animals. This vertical zonation is a fundamental aspect of river ecology throughout the region. Finland's river systems present a somewhat different pattern, with most major rivers flowing through a landscape dominated by countless lakes. The Finnish Lake District contains approximately 55,000 lakes larger than 200 meters across, creating a complex hydrological network where rivers often appear as connecting segments between lake basins. The Vuoksi River system, which includes Lake Saimaa, Finland's largest lake with a surface area of 4,400 square kilometers, exemplifies this pattern. The actual river segments may be relatively short, but they form part of extensive watersheds that effectively drain large portions of the country. The Torn River, mentioned earlier, demonstrates many typical features of northern Scandinavian waterways. Its headwaters originate in Lake Torneträsk, situated approximately 70 kilometers north of the Arctic Circle at an elevation of 342 meters above sea level. From this source, the river flows southeastward, initially through a valley with moderate gradient before entering flatter terrain. As it approaches the Gulf of Bothnia, it forms a delta-like estuary with multiple channels separated by low islands. This pattern of river morphology, from relatively steep headwaters to multi-channeled lower reaches, is repeated in many of the region's larger rivers. The river width varies considerably along its course, from narrower sections less than 100 meters across to broader reaches exceeding 500 meters. Depth similarly varies, typically ranging from 2 to 5 meters in mid-channel during normal flow conditions, though pools exceeding 10 meters in depth occur at intervals, particularly where the river's course makes abrupt turns. These deeper sections often serve as important overwintering habitat for fish species, providing refuge when surface ice forms during the long northern winter. The cross-sectional profile of Scandinavian rivers typically follows patterns common to all alluvial waterways, with a generally U-shaped channel that may be asymmetrical, particularly on bends, where outer banks experience greater erosive forces. The substrate composition transitions from predominantly larger materials like boulders and cobbles in upper reaches to gravels, sands, and eventually silts and clays in lower sections. This sorting of material results directly from the river's decreasing transport capacity as gradient decreases downstream. Tributaries join the main stem of each river at intervals, creating a dendritic, tree-like drainage pattern when viewed from above. Each tributary adds its flow to the main channel, incrementally increasing the volume of water moving downstream. Major confluences often create distinctive riverine features, with visible mixing zones where waters of different temperatures or sediment loads merge. These junction points frequently develop deeper sections due to the complex hydraulics created where channels meet. The longitudinal profile of a typical Scandinavian river, when graphed as elevation versus distance, produces a concave curve that becomes progressively less steep toward the river mouth. This profile represents the river's ongoing adjustment toward a theoretical equilibrium state, though true equilibrium is never reached due to ongoing geological processes and climate fluctuations. The profile of the Glomma River in Norway, for instance, shows a steep upper section where it drops approximately 1,000 meters over its first 150 kilometers, followed by a much gentler gradient for its remaining 470 kilometers to the sea. River valleys in the region exhibit forms strongly influenced by their glacial history. In western Norway, rivers often flow through classic U-shaped valleys carved by glaciers, with steep sides rising hundreds of meters above the valley floor. As these valleys approach the coast, they may become fjords, deeply incised valleys that have been flooded by the sea as ice retreated and sea levels rose. In contrast, river valleys in eastern Sweden and Finland typically have gentler profiles, with broad floodplains that may extend several kilometers on either side of the active channel. The floodplains that develop along middle and lower reaches of Scandinavian rivers create important ecological transition zones between aquatic and terrestrial environments. These areas experience periodic inundation, particularly during spring floods, depositing nutrient-rich sediments that support distinctive plant communities. The extent of these floodplains varies considerably, from relatively narrow bands along confined valley sections to extensive plains several kilometers wide in lower gradient reaches. Riverbed morphology includes features common to alluvial systems worldwide, though perhaps less pronounced due to the resistant nature of much of the underlying bedrock. Riffle pool sequences develop where adequate sediment supplies exist, creating rhythmic alternations between shallower, faster flowing sections, riffles, and deeper, slower flowing areas, pools. The spacing of these features typically correlates with channel width, with pools occurring approximately every 5 to 7 channel widths under ideal conditions. Islands occur frequently in many Scandinavian rivers, particularly in lower reaches where channel gradients decrease, and the river may adopt a braided pattern with multiple channels. These islands, locally called home in Swedish or sari in Finnish, create complex hydraulic environments and often support distinctive ecological communities slightly different from those of the mainland riparian zones. Over time, islands may stabilize through vegetation succession, becoming permanent features of the riverscape, or they may erode during flood events, demonstrating the dynamic nature of these fluvial systems. When we examine Scandinavian rivers from a statistical perspective, patterns emerge that help us understand the regional hydrology. The total number of rivers in Scandinavia exceeding 100 kilometers in length is approximately 60, with Sweden having the greatest number at 30, followed by Norway with 18 and Finland with 12. However, if we include rivers exceeding 10 kilometers in length, the number increases dramatically to over 4,000 across the region, demonstrating the dense hydrological network that characterizes this northern landscape. The combined total length of all rivers and streams in Scandinavia exceeds 280,000 kilometers, roughly equivalent to 7 circumnavigations of the Earth at the equator. This extensive network drains a total land area of approximately 750,000 square kilometers, creating a drainage density, stream length per unit area, of about 0.37 kilometers of waterway per square kilometer of land. This figure is relatively high compared to global averages, reflecting both the humid climate and the impermeable nature of much of the bedrock. Annual precipitation across Scandinavia varies considerably, from approximately 300 millimeters in the northern interior regions to over 2,000 millimeters along parts of the Norwegian west coast. This variation creates significant differences in river discharge patterns. The average annual runoff, precipitation minus evapotranspiration, ranges from about 200 millimeters in southeastern Sweden to over 1,500 millimeters in western Norway. This translates to average annual water yields ranging from 6.3 liters per second per square kilometer in western Norwegian watersheds to less than 1 liter per second per square kilometer in some eastern Swedish and Finnish watersheds. The Gerda River system, including Lake Vänern and all its tributaries, drains approximately 50,000 square kilometers, making it the largest watershed in the region. Its average discharge of 550 cubic meters per second represents approximately 13% of Sweden's total freshwater runoff to the sea. The watershed includes areas with varying precipitation patterns, soil types, and land uses, creating a complex hydrological system that responds differently to seasonal changes and extreme weather events across its vast area. The Glomma River in Norway, flowing for 621 kilometers, ranks as the longest river entirely within Scandinavia. It drains a watershed of approximately 41,200 square kilometers, representing roughly 13% of Norway's total land area. Its average discharge of 720 cubic meters per second makes it also the most voluminous river in the region. The Glomma's flow regime is characterized by a pronounced spring flood, typically occurring in May or June, when discharge can exceed 3,500 cubic meters per second, nearly 5 times the annual average. In terms of water chemistry, Scandinavian rivers generally exhibit low mineral content, with total dissolved solids typically ranging from 20 to 100 milligrams per liter. This reflects the predominance of hard, crystalline bedrock throughout much of the region. pH values range from slightly acidic, pH 5.565, in rivers draining areas dominated by coniferous forests and peatlands, to circumneutral, pH 6.575, in watersheds with greater proportions of deciduous forest or agricultural land. These chemical characteristics influence the biological communities that develop within each river system. Water temperature patterns in Scandinavian rivers follow predictable seasonal cycles, though with considerable variation between northern and southern watersheds. In southern rivers, water temperatures typically range from near freezing, 0-1 degrees C, in winter, to summer maximums of 18-22 degrees C. In contrast, rivers north of the Arctic Circle may remain below 4 degrees C for more than 6 months of the year, with summer maximums rarely exceeding 15 degrees C. These thermal regimes create important constraints on aquatic ecosystems, limiting the species that can successfully complete their life cycles in more northern watersheds. Ice formation on rivers follows a relatively predictable pattern across the region, with northern rivers typically developing complete ice cover by late October or early November, while southern waterways may not freeze completely until December or January, if at all. The timing of spring ice breakup similarly follows a latitudinal gradient, typically occurring in April in southern rivers and May or even early June in the far north. This ice regime creates distinctive seasonal patterns in river hydrology, with reduced flows during winter ice cover, followed by dramatic increases during spring breakup. The sediment transport characteristics of Scandinavian rivers differ markedly from those in regions with more erodible landscapes. Annual suspended sediment loads typically range from 5 to 30 tons per square kilometer of watershed area, significantly lower than global averages for rivers of similar size. This reflects both the resistant nature of the bedrock and the extensive forest cover that minimizes soil erosion across much of the region. The relatively modest sediment loads contribute to the exceptional clarity of many Scandinavian rivers, with visibility often exceeding 5 meters during low flow periods. Examining the relationship between Scandinavian rivers and surrounding landscape features reveals interesting patterns. Approximately 68% of the region's river length flows through forested landscapes, 14% through agricultural areas, 12% through wetlands or peatlands, and the remaining 6% through urban or mountainous terrain devoid of significant vegetation. These percentages reflect the predominance of forest cover across the region, particularly coniferous forest, that creates the characteristic dark green corridors following many river valleys. The interconnection between rivers and lakes creates a distinctive aspect of Scandinavian hydrology, particularly in Finland and parts of eastern Sweden. Approximately 42% of Finland's major rivers flow through at least one significant lake basin along their course, creating complex flow patterns where river characteristics alternate with lacustrine environments. This lake-river continuum creates a mosaic of habitats that supports greater biodiversity than either habitat type alone, contributing to the ecological importance of these waterways. River sinuosity, the ratio of channel length to straight line distance, varies considerably across the region, typically correlating with valley gradient. In steep mountain valleys, sinuosity values typically range from 1.1 to 1.3, indicating relatively straight channels controlled by valley morphology. In contrast, rivers flowing through flatter terrain, particularly in Finland and eastern Sweden, may develop sinuosity values exceeding 2, creating meandering channels that effectively double the distance water travels compared to the straight line valley length. The river density across Scandinavia, measured as total channel length per unit area, averages 0.37 kilometers per square kilometer, but varies considerably by region. Western Norway, with its steep topography and numerous small streams, has density values exceeding 0.5 kilometers per square kilometer in many watersheds. In contrast, flatter regions of Finland may have density values below 0.25 kilometers per square kilometer, reflecting the dominance of lakes rather than flowing channels in the overall hydrological network. The average flow velocity in major Scandinavian rivers typically ranges from 0.2 to 0.5 meters per second during normal flow conditions, though considerable variation occurs both seasonally and spatially. During spring floods, velocities may exceed 2 meters per second in confined channel sections, while backwater areas may experience essentially zero flow during low water periods. This variation creates a mosaic of hydraulic conditions that supports diverse ecological communities adapted to different flow environments. Examining the directional orientation of major Scandinavian rivers reveals that approximately 52% flow generally eastward or southeastward, 28% flow southward, 15% flow westward, and only 5% flow northward. This pattern reflects the fundamental influence of the Scandinavian mountains as the primary watershed divide, directing most drainage either toward the Baltic Sea to the east or the North Sea to the south and west. The relatively few northward flowing rivers occur primarily in the far northern regions of Finland and Sweden, where local topography overrides the general regional pattern. The climate of Scandinavia creates distinctive seasonal patterns in river hydrology that have remained relatively consistent for thousands of years. Despite its northern latitude, the region experiences a climate moderated by the influence of the Gulf Stream, which brings warmer water and air masses to western coastal areas. This moderating effect diminishes eastward, creating a gradient from relatively mild maritime conditions along the Norwegian coast to more continental conditions in eastern Sweden and Finland. Annual precipitation patterns show considerable regional variation, with western Norway receiving the highest amounts due to orographic lifting of moisture-laden air masses from the Atlantic. As these air masses rise over the Scandinavian mountains, they cool and release moisture, creating annual precipitation totals exceeding 2,000 millimeters in some mountain areas. East of the mountains, in the rain shadow, precipitation decreases markedly, with parts of eastern Sweden and Finland receiving less than 500 millimeters annually. This precipitation gradient creates fundamental differences in river flow regimes across the region. The seasonal distribution of precipitation also varies across Scandinavia. Coastal western areas typically experience maximum precipitation during autumn and winter, while inland regions further east receive maximum precipitation during summer months. This difference creates contrasting seasonal flow patterns, with western rivers often experiencing highest flows during late autumn or winter, while eastern rivers typically peak during spring snowmelt. Rivers flowing from the mountains may show combined patterns, with both winter rain floods and spring snowmelt peaks occurring in different years, depending on specific weather conditions. Temperature patterns across Scandinavia follow predictable seasonal cycles, with January typically being the coldest month and July the warmest. Mean January temperatures range from approximately 0 degrees C along the southwestern Norwegian coast to below degrees C in the northern interior. July mean temperatures range from 12 degrees C in the far north to 18 degrees C in southern regions. These temperature patterns, particularly winter temperatures, strongly influence river ice regimes and the timing of spring snowmelt, which in turn affects annual flow patterns. Snow accumulation during winter months represents a significant form of water storage in Scandinavian watersheds. Average annual maximum snow depths range from less than 20 centimeters in coastal southwestern areas to over 200 centimeters in mountain regions. The water equivalent of this snowpack, the depth of water that would result if the snow melted completely, typically ranges from less than 50 millimeters in southern coastal areas to over 500 millimeters in northern mountain regions. This stored water is released during spring melt, creating the characteristic annual flood cycle in many rivers. The timing of snowmelt follows a predictable pattern, beginning in southern regions in March or April and progressively moving northward, reaching the far north by May or early June. This temporal progression creates a wave of high flows that moves through the river networks, typically lasting 2-4 weeks at any given location, depending on watershed size and the depth of accumulated snow. During this period, rivers may carry 30–50% of their total annual water volume, demonstrating the hydrological significance of this seasonal event. Ice formation on Scandinavian rivers typically begins along shorelines in late autumn, gradually extending across the channel as water temperatures drop below freezing. Complete ice cover develops first on smaller, slower flowing rivers, while larger or faster flowing channels may maintain open sections throughout winter, particularly at rapids or constrictions where turbulence prevents ice formation. Ice thickness by late winter typically ranges from 30 to 60 centimeters in southern rivers to over 100 centimeters in the far north, creating a significant seasonal modification to river morphology and hydraulics. Spring ice breakup represents a dramatic annual event on many Scandinavian rivers, particularly those flowing northward, where the progression of spring temperatures moves against the flow direction. As ice in headwater regions begins to melt, while downstream sections remain frozen, water and ice accumulate behind these natural dams, creating the potential for sudden releases when downstream ice finally yields. These ice jam floods can create water levels significantly higher than those caused by equivalent discharge under ice-free conditions, occasionally causing damage to riverside infrastructure. The annual hydrograph, a graph showing discharge versus time of a typical Scandinavian river, reveals distinctive seasonal patterns. Rivers in western Norway often show a bimodal pattern, with peaks during autumn-winter rainfall and spring snowmelt. In contrast, rivers in eastern Sweden and Finland typically show a single pronounced peak during spring snowmelt, followed by gradually decreasing flows through summer and autumn, reaching minimum levels during late winter before the next melt cycle begins. These patterns reflect the combined influence of precipitation timing and temperature regimes across the region. Evapotranspiration, the combined loss of water through evaporation from surfaces and transpiration from plants, represents a significant component of the regional water balance, though less dominant than in warmer climates. Annual potential evapotranspiration ranges from approximately 400 millimeters in southern regions to less than 300 millimeters in the far north. Actual evapotranspiration is typically 20–30% lower due to limited water availability during certain periods. This relatively modest evaporative demand helps explain the high proportion of precipitation that eventually reaches rivers and streams. Base flow, the portion of river discharge derived from groundwater rather than direct runoff, varies seasonally and geographically across Scandinavia. In regions with substantial glacial deposits or fractured bedrock aquifers, base flow may constitute 30–40% of annual discharge, creating relatively stable flow conditions throughout the year. In contrast, areas with thin soils over impermeable bedrock may experience base flow contributions below 20%, resulting in more variable discharge patterns with pronounced high and low extremes. Low flow conditions typically occur during two distinct seasonal periods across the region. In winter, when precipitation falls as snow and is effectively stored in the snowpack, rivers experience reduced flows, particularly in northern regions where the winter period extends for many months. A secondary low flow period often occurs during late summer, particularly during dry years when precipitation is insufficient to overcome evapotranspiration demands. These seasonal low flow periods create natural stresses on aquatic ecosystems to which native species have adapted over evolutionary time. Flood events in Scandinavian rivers occur with fairly predictable seasonal timing, though with considerable variation in magnitude from year to year. The annual probability of flooding, the chance that discharge will exceed the river's channel capacity in any given year, ranges from approximately 10% for smaller floods that may occur relatively frequently to less than 1% for extreme events that represent rare natural disasters. The majority of significant floods are associated either with spring snowmelt or with intense autumn rainfall events, particularly when these coincide with soils already saturated from previous precipitation. Climate influences on water temperature follow seasonal patterns that affect all aspects of river ecology. Surface water temperatures in major rivers typically range from near 0 degrees C during winter months to summer maximums of 15–22 degrees C, depending on latitude and elevation. The annual temperature range decreases with increasing channel size, as larger water volumes have greater thermal inertia and respond more slowly to changing air temperatures. This buffering effect creates more stable thermal environments in larger rivers compared to smaller tributaries. Diurnal temperature fluctuations, changes between day and night, are most pronounced during summer months and in smaller channels. Typical daily temperature ranges in small to medium-sized rivers during summer may reach 3-5 degrees C, while larger rivers may show variations of less than 2 degrees C. These daily cycles create microscale temporal habitat variations that influence the behavior and distribution of temperature-sensitive aquatic organisms. The relationship between climate patterns and water chemistry creates seasonal variations in parameters such as dissolved oxygen, pH, and nutrient concentrations. Oxygen levels typically reach maximum values during winter months when cold water temperatures increase gas solubility, often approaching or exceeding 12 milligrams per liter. During summer, when warmer temperatures reduce oxygen solubility and biological oxygen demand increases, concentrations may drop to 7-9 milligrams per liter, particularly in slower flowing sections with abundant organic material. Climate change projections for Scandinavia generally anticipate warmer temperatures and increased precipitation, particularly during winter months. Models suggest winter temperature increases of 2-5 degrees C by mid-century, potentially reducing snow accumulation and altering the timing of spring melt. Precipitation projections indicate increases of 10–30% during winter months, but more variable changes during summer. These shifts would fundamentally alter river flow regimes, potentially reducing the magnitude of spring floods while increasing winter discharge, a significant departure from historical patterns. Human settlement patterns along Scandinavian rivers reflect thousands of years of practical adaptation to landscape and available resources. Archaeological evidence indicates that early inhabitants were drawn to river mouths and confluences, where fishing opportunities were greatest and natural transportation routes converged. As agricultural practices developed, particularly during the Bronze Age, approximately 1700–500 BCE, settlement expanded along river valleys where alluvial soils offered more fertile conditions than surrounding forested regions. Population density along major river corridors averages approximately 18 people per square kilometer, considerably higher than the regional average of approximately 14 people per square kilometer. This pattern reflects both historical settlement preferences and continuing advantages associated with riverside locations. However, substantial variation exists, from essentially uninhabited stretches in northern regions to urban centers exceeding 1,000 people per square kilometer, where major cities have developed at strategic river locations. Land use patterns within Scandinavian river watersheds reflect both environmental constraints and cultural preferences developed over centuries. Forest remains the dominant land cover, occupying approximately 61% of the total area. Agricultural land comprises approximately 8%, with concentration in southern regions where climate and soils are more favorable. Wetlands and peatlands cover approximately 15%, while urban areas, transportation infrastructure, and other developed uses account for the remaining 16%. These percentages have remained relatively stable over recent decades, with only modest shifts among categories. The development of hydroelectric power represents a significant human modification to Scandinavian river systems. Norway leads the region in hydropower capacity, with approximately 31,000 megawatts installed, representing about 96% of the country's electricity production. Sweden follows with approximately 16,000 megawatts, while Finland has developed about 3,100 megawatts. These installations have modified flow regimes on many rivers, typically reducing peak flows during flood periods and increasing minimum flows during traditional low water periods, creating more uniform discharge patterns throughout the year. Transportation infrastructure associated with rivers includes approximately 7,800 bridges crossing waterways throughout the region. These range from simple timber structures serving forest roads to major engineering works carrying highways or railways across the largest rivers. The density of bridge crossings correlates strongly with population density, ranging from less than 0.1 bridges per kilometer of river in remote northern areas to more than 2 bridges per kilometer in urbanized southern regions. River regulation for flood control and other purposes has resulted in approximately 420 significant dams throughout Scandinavia, with the highest concentrations in the more developed southern watersheds. These structures range from simple weirs raising water levels by less than 1 meter to major impoundments creating reservoirs exceeding 100 kilometers in length. The total storage capacity of these reservoirs approaches 120 cubic kilometers, equivalent to approximately 15% of the region's annual runoff, providing significant capacity for flow regulation. Navigation on Scandinavian rivers played a crucial historical role, but has diminished in modern times with the development of alternative transportation modes. Currently, commercial navigation occurs on approximately 1,200 kilometers of rivers region-wide, primarily in southern Sweden. The most significant navigable waterway is the Gerda Canal system, which, combined with lakes and river sections, creates a 390-kilometer navigable route across southern Sweden from Gothenburg to Stockholm. This system includes 58 locks, overcoming a total elevation difference of 91 meters. Fishing activities on Scandinavian rivers include both recreational and, to a lesser extent, commercial practices. Approximately 1.8 million fishing licenses are issued annually across the region, with salmon, trout, grayling, and pike being the most sought-after species. The economic value of recreational fishing is estimated at approximately 500 million euros annually, including direct expenditures on equipment, accommodations, and guide services. commercial fishing on rivers has declined significantly over recent decades and now represents a minor economic activity, though still culturally significant in some communities. Water extraction for human use from Scandinavian rivers totals approximately 6.8 billion cubic meters annually, representing less than 2% of total river discharge. This relatively modest utilization reflects both the abundant water resources of the region and the relatively small population. Approximately 48% of extracted water serves municipal purposes, 35% industrial uses, and the remaining 17% agricultural needs, primarily irrigation during occasional summer dry periods in southern agricultural regions. The water quality of Scandinavian rivers generally ranks among the highest in Europe, though with notable exceptions in more developed watersheds. Monitoring programs measure parameters at approximately 1,200 stations region-wide, assessing both chemical and biological indicators based on European Union Water Framework Directive criteria. Approximately 76% of monitored river sections achieve good or high ecological status, compared to a European average of approximately 44%. This favorable condition reflects both relatively low population density and stringent environmental regulations implemented since the 1970s. Administrative boundaries related to river management create a complex governance landscape across the region. Watershed management is divided among approximately 110 water districts, each with responsibilities for planning and implementing measures to maintain or improve ecological status. Transboundary watersheds, particularly those shared between Sweden and Finland, or Norway and Sweden, operate under cooperative agreements that have generally functioned effectively to address common concerns. The oldest of these agreements dates to 1929, though most current arrangements were established during the 1990s or early 2000s. Tourism associated with Scandinavian rivers generates approximately 720 million euros annually, with activities including recreational fishing, kayaking, rafting, and nature observation. The number of visitor days specifically focused on river-based recreation exceeds 2.2 million annually, with the highest concentrations in scenic western Norwegian fjord regions and in areas offering premium fishing opportunities for prized species like Atlantic salmon. This tourism creates approximately 8,400 direct jobs region-wide, primarily seasonal positions during the summer months when visitor numbers peak. The historical development of settlements along Scandinavian rivers follows patterns common to many regions, with early communities establishing at locations offering natural advantages. These typically included river confluences, where tributary streams joined larger channels, rapids, or waterfalls, where fish concentration made harvesting more efficient, natural harbors, where boats could safely anchor, and fordable sections where rivers could be crossed with relative ease. Many modern communities trace their origins to these naturally advantageous locations, though contemporary infrastructure has reduced the significance of many historical constraints. Industrial development along Scandinavian rivers began in earnest during the 18th and 19th centuries, with water-powered mills established for processing timber, grinding grain, and operating simple machinery. By the early 20th century, larger-scale industries had developed at locations offering both water power and transportation access, including paper mills, metal works, and textile factories. While many of these historical industrial sites have been repurposed or abandoned as economic patterns shifted, their legacy remains visible in the urban landscapes of many riverside communities. Forestry practices in riparian zones, the areas directly adjacent to rivers, have evolved considerably over recent decades. Current regulations typically require buffer zones ranging from 5 to 30 meters wide, depending on stream size and local conditions, where timber harvest is prohibited or strictly limited. These protective corridors serve multiple ecological functions, including stabilizing banks, filtering runoff, providing shade to moderate water temperatures, and supplying organic material that supports aquatic food webs. The total area encompassed by these riparian protection zones across Scandinavia exceeds 600,000 hectares. Agricultural activities adjacent to major rivers occupy approximately 980,000 hectares region-wide, primarily in southern Sweden and Denmark, where climate and soils are most favorable. Typical crops include cereals, primarily wheat, barley, and oats, oilseeds, primarily rapeseed, and forage crops supporting dairy and beef production. Field sizes average approximately 4.2 hectares, considerably smaller than in many other European agricultural regions. This relatively small-scale pattern creates a mosaic landscape with frequent hedgerows, tree lines, and other non-crop elements that provide habitat diversity within the agricultural matrix. Wildlife management in relation to river corridors focuses particularly on migratory fish species and riparian mammals such as beaver and otter. Fish passage facilities have been constructed at approximately 280 dams and other barriers throughout the region, with varying designs depending on target species and site conditions. These range from simple rock ramps to elaborate fish elevators at major hydroelectric facilities. Monitoring programs indicate passage efficiency. The percentage of approaching fish that successfully navigate the structure ranging from 40% to 95%, depending on design, target species, and local conditions. River names throughout Scandinavia reflect linguistic patterns that have evolved over centuries. Approximately 40% of major rivers bear names with pre-Germanic origins, many dating to Sami or even earlier linguistic roots. These oldest names typically refer to simple characteristics like big water, or swift flow. Names with Germanic origins, accounting for approximately 45% of major rivers, often combine descriptive elements with suffixes indicating river or stream. The remaining 15% have more recent origins, including names referencing settlements, historical events, or important individuals. Though these more recent names apply primarily to smaller tributaries rather than main stems, the annual maintenance costs for river-related infrastructure throughout Scandinavia, including dams, levees, navigation facilities, monitoring stations, and recreational access points, totals approximately 340 million euros. This expenditure is divided among national governments, approximately 42%, regional authorities, 31%, municipalities, 18%, and private entities, such as hydropower companies, 9%. The distribution of these costs reflects the mixed ownership and responsibility patterns that characterize river management throughout the region. Sedimentation patterns in reservoirs created by dams show considerable variation depending on watershed characteristics and reservoir operations. Annual accumulation rates range from less than 0.1 centimeters in reservoirs draining primarily forested watersheds to over 1 centimeters in those receiving sediment from agricultural areas or glacial sources. The total volume of sediment accumulated in all Scandinavian reservoirs, since their construction is estimated at approximately 850 million cubic meters, representing a reduction in storage capacity of about 0.7% from original design specifications. Flood management strategies have evolved over recent decades, shifting from primarily structural approaches focused on containing high flows to more integrated approaches incorporating floodplain management and ecological considerations. Approximately 320 kilometers of major rivers are protected by engineered levees, primarily in urban areas and valuable agricultural regions. However, managed retreat from flood-prone areas has become increasingly common, with approximately 4,800 hectares of former developed or agricultural land intentionally returned to natural floodplain functions since 2000. Urban river restoration projects have increased substantially over recent decades, with approximately 140 significant initiatives completed since 1990. These projects typically involve removing concrete channelization, recreating meanders in previously straightened sections, establishing riparian vegetation, and creating public access points. The average cost of these projects is approximately 1.2 million euros per kilometer of restored channel, with funding typically shared among multiple sources, including municipal governments, national environmental agencies, and the European Union. Groundwater surface water interactions along Scandinavian rivers create complex hydrological patterns that influence both water quantity and quality. In regions with extensive glacial deposits, particularly in Denmark and southern Sweden. River flows may be strongly influenced by groundwater inputs, with base flow comprising up to 70% of annual discharge. In contrast, rivers flowing over crystalline bedrock with thin soil cover may receive less than 20% of their flow from groundwater, resulting in more variable discharge patterns. These differences create distinct ecological conditions that influence species composition and abundance patterns. River place names often reflect historical human activities or landscape features now long vanished. Approximately 380 settlement names across the region incorporate elements referring to mills, 260 reference fords or crossing points, 195 indicate fishing locations, and 140 refer to harbors or landing places. These linguistic fossils provide insights into historical relationships between communities and their adjacent waterways, often preserving information about uses or features that physical evidence alone would not reveal. The administrative complexity of river management is reflected in the overlapping responsibilities of various entities. Depending on the specific waterway and issue, management may involve municipal governments, regional authorities, national agencies, international commissions, or private stakeholders. A typical major river in the region may fall under the jurisdiction of 6 to 12 different administrative entities, with responsibilities ranging from water quality monitoring to flood management, hydropower regulation, navigation maintenance, fishing regulation, and recreational access. Coordination among these entities occurs through approximately 40 permanent commissions or working groups region-wide. Temperature patterns in Scandinavian rivers have shown modest but measurable changes over recent decades, with average annual water temperatures increasing by approximately 0.3 degrees C since 1980. This warming trend has been most pronounced during summer months and in southern watersheds. While seemingly small, such temperature changes can significantly influence aquatic ecosystems, particularly for cold water species operating near their thermal tolerance limits. Continued monitoring of these trends represents an important component of regional climate change research. The cultural significance of rivers in Scandinavian folklore and literature spans centuries, with waterways featuring prominently in early myth cycles, medieval ballads, and contemporary creative works. Rivers appear in approximately 220 folk tales documented across the region, variously depicted as boundaries between worlds, homes of supernatural beings, sources of sustenance, or pathways for travel. This cultural heritage continues to influence contemporary relationships with rivers, reinforcing their importance beyond merely practical considerations. Recreational use patterns show strong seasonal variations, with approximately 68% of all river-focused recreational activities occurring during the 3 summer months of June, July, and August. The remaining use is distributed primarily during spring and autumn, with minimal winter activity except in specific locations known for ice fishing. Annual surveys indicate approximately 7.6 million recreational visits to major Scandinavian rivers, generating approximately 230 million euros in direct economic impact to local communities through expenditures on accommodations, food, equipment, and services. Monitoring programs track both chemical and biological parameters at established stations throughout the river networks. Standard measurements include physical parameters, temperature, flow, turbidity, basic water chemistry, pH, conductivity, dissolved oxygen, nutrient concentrations, nitrogen and phosphorus compounds, biological indicators, macroinvertebrate communities, fish populations, algal growth, and in some locations, contaminants such as heavy metals or persistent organic pollutants. The total annual cost of these monitoring programs, region-wide, exceeds 18 million euros, reflecting the substantial commitment to understanding and protecting these waterways. The economic value of ecosystem services provided by Scandinavian rivers, including water purification, flood regulation, habitat provision, and recreational opportunities, has been estimated at approximately 5.2 billion euros annually using various valuation methodologies. This figure, while necessarily approximate given the challenges of economic valuation for natural systems, nonetheless helps illustrate the significant contributions these waterways make beyond more easily measured direct uses, such as hydropower production or water supply. Recognition of these broader values has gradually influenced management decisions, particularly regarding restoration priorities and minimum flow requirements. River crossings throughout history have created natural focal points for settlement and commerce. Approximately 620 modern communities across Scandinavia originated at locations where rivers could be forded or bridged, with many place names explicitly referencing this origin. The traditional importance of these crossing points has diminished with modern transportation infrastructure, as bridges now span even the largest rivers at multiple points. But the historical pattern remains visible in settlement distribution. Archaeological evidence indicates that some crossing points have been in continuous use for over 2,000 years, despite dramatic changes in the societies utilizing them. The human history written in riverbank sediments provides fascinating insights into past activities and conditions. Sediment cores from floodplain deposits reveal layers containing evidence of historical land clearance, industrial development, and pollution episodes. Analysis of these cores shows, for example, that lead concentrations in river sediments peaked during the 1970s at levels approximately 12 times higher than pre-industrial baseline, before declining following implementation of environmental regulations. Similar patterns appear for other contaminants, creating a detailed chronicle of changing human impacts over centuries. As our journey along the gentle rivers of Scandinavia draws toward its conclusion, we might reflect on the quiet persistence of these waterways flowing through ancient landscapes. From their sources in mountain heights or forest springs, through their middle reaches meandering across plains and through lakes, to their final passages to the embracing seas, these rivers embody continuous, unhurried movement that has shaped both natural and human landscapes for millennia. The statistical details, measurements, and factual information we have explored may fade from memory, much as small tributaries merge into larger channels and lose their individual identities. What remains is the impression of these waters, their constant presence, their gentle sounds, their reflective surfaces mirroring sky and forest, their endless journey from highlands to sea. This cycle continues regardless of human attention, a natural rhythm that long preceded our awareness and will continue long after. The rivers of Scandinavia flow at their own pace, untroubled by schedules or deadlines, neither hurried nor delayed by external expectations. Perhaps in this quality lies their greatest lesson, the value of moving steadily toward one's destination, flowing around obstacles rather than struggling against them, and finding the path of least resistance through the landscape. Water shapes the land gradually through persistence rather than force, creating beauty through patient action over countless days and nights. As you continue into your own peaceful night, imagine yourself beside one of these northern rivers, where water flows with gentle sounds over ancient stones, where forests grow tall along the banks, and where the cycle of movement has continued uninterrupted since the last ice retreated. Let your thoughts drift like leaves on the current, carried without effort, traveling without purpose beyond the simple journey itself. Allow the steadiness of flowing water to carry you forward into comfortable rest, just as these rivers have carried the land's stories forward through countless years. The rivers continue their journey as you begin yours into peaceful sleep, each flowing according to natural rhythms, each following the contours of its own landscape, each moving steadily toward the horizon at its own perfect pace. As consciousness gently recedes like ebbing water, know that the rivers of Scandinavia continue their timeless passage, flowing onward through the quiet northern night.